Hello, everyone. Welcome to another bounty episode of the Day Zero podcast. And today we have a good mix of topics, including an account takeover in Booking.com, breaking some SmartLocks, and some other stuff. So, we'll get into our first topic. Just jump into it here, which is from Salt Labs. And it's centered around an account takeover in Booking.com, which is like a vacation booking site, and it's support for logging in through Facebook via OAuth. So, Z, I'll let you take this one away.
Yeah, and this is just a fun little OAuth issue. They basically start off, or as Spectre already mentioned, they're kind of dealing with the Facebook implementation, and they kind of have a few things going on here. They call out three security gaps, one of which I don't totally agree with calling it a security gap. Get into that. But two of which are kind of on the main OAuth flow to getting the code, and then the last one, is actually more towards a security feature that they're then able to bypass. I'll just jump into it here. The first security gap they notice or call out with their actual OAuth process is just the fact that you can kind of redirect it off to any location. It's fair to call out, it's fair to notice. Like, it can be an issue. I think it's fairly common in a lot of OAuth systems that you verify the origin of it, but not necessarily the entire path of every redirect URI. So it's fair to know, like, that is something that can create issues, and they are able to abuse that here. But it's also not terribly uncommon for applications to only even let you verify just the origin. Like, I don't know what Facebook's looks like, but I know Google, they only really do the origin validation, just like what is the host name that you're going back to. So when it's not even an option to actually set it up, I have a hard time saying it's a security gap. Like, it is a problem. I can agree to that much. Like, ideally, you'd be able to lock it down tighter. Nonetheless, that's what they notice. So that opens up for the opportunity of some sort of open redirect being used. You have an open redirect on that same origin. So in this case, on account.booking.com, you have an open redirect. Then you could set up your redirect URI for the OAuth, give that to a victim. They give redirected back to the open redirect, and then off to an attacker who can actually exfil the code that Facebook gave back. And that's a fairly standard kind of technique to go about. They did indeed find that's their second security gap, the open redirection. They did indeed find that issue and were able to exfil the code. I did think that the open redirect was really odd in the way they existed here. The open redirect in the dashboard on Booking.com, you had this ability to add a display name, and it would link off to this rather large URL that included, like, it looks like an OAuth URL because you've got the OAuth 2/authorize, client ID in there, redirect URI, and the state. You have all of that in there. I don't know, when you're linking just to like one thing, I don't know why it's going through this flow, and they don't really talk about it. But they do talk about how this state value is a JSON blob that's just been base64 encoded. And inside of that JSON blob is this my settings path, which they could just give a URL they want to redirect to. So that's how they're able to create open redirect outfit. Super weird flow. I'm not sure what exactly is going on here. Maybe if I use the application, it would make a little bit more sense as to what they're trying to do. But it is just very weird to see this sort of flow going on and passing a redirection URL in that way. But that's how they're able to create the redirect URL. It existed, so be aware of it, I guess. It's weird. It's honestly kind of a weird setup to me. Nonetheless, they get the open URL, or they get the open redirection, so they can exfil the code. Now, usually, that's pretty much game over. You get that code, you pop it into your own login attempt, and you act like you tried to log in as a user. However, they found in this case, Facebook was actually doing a bit of an extra check. It would actually validate, so when, as part of the normal flow, or with the code flow, Booking.com would get this code back from Facebook. Booking.com would then need to take that code, send it over along with their client secret, and they would exchange that for the actual token that could be used on Facebook. And in doing that exchange, they also had to include, or at least were including, the redirect URL that should have been used when issuing that initial code. And so because of the open redirect in use, that redirect URI no longer matched. It was using, as they first thought, it wasn't, but the first thought was it was using like a hard-coded path because they're expecting all of their OAuth calls to come in, or to come back to this one particular, basically their catcher for it. They're expecting it to come there, so that's the redirect URL they provide. And so Facebook sees that's like, wait, this isn't the redirect URL I used when issuing this token. Something's going on here, and just fails. Which is, good on Facebook's part for doing that. But then they need to find a way to gain control over the redirect URI that was passed, which is their third security gap. Which again, kind of had a bit of a weird flow going on within the application. They have this lovely chart, which I'll admit is a little bit hard to follow. But what kind of ends up happening here is you have to log in on Facebook. You go through the normal flow over here. Sorry for those of you who can't see, but effectively you have the normal flow where the code comes back. But the page that actually catches that code, so the redirect URL targets, Facebook redirects to it, that will go to Booking.com's backend. And then it does this redirect back to kind of a custom protocol that acts as the Facebook redirect in the mobile application, who then sends the code again back over to Booking. So it kind of has this bounce back and forth, where it sends it to Booking to redirect to a deep link, to send it over to Booking again. And it's in that second call over to the Booking application where it actually sends the results URI as one of the parameters inside of there, which gets reflected as the redirect URI that it uses when it does the code exchange, allowing them to intercept that code and effectively log in on the account. So they had a bit of an extra step in there. I thought it was really interesting to see a couple of these weird things that Booking.com was doing. That really weird open redirect with the state variable. And not crazy to see like basics for encoded JSON, but in that flow, I don't get what's going on there. And seeing the results URI just getting passed so neatly back, because if they didn't have that, this would have been reasonably secure, at least from being able to use this token, had they just hard-coded that value and kind of known what the redirect URI should have been, using either a whitelist or something like that, or not even giving the attacker control over them. Because it doesn't...
Yeah.
Go ahead.
I was just going to say, like, there was a few things here that I found interesting. One of which was that my settings path was able to hit like a remote domain at all. So I don't think we really talked about this too much, but when they talked about the my settings path that was in that state object, the way they abuse that is they basically make that my settings path point to a remote, like, attacker controlled URL. I would think that they would want to lock that down to, because like you can see like the default value they have there is just the relative my settings personal path. It seems a bit weird that they would like allow and follow remote URLs there.
My assumption on that would be that they're not actually aware of the fact that it's kind of like supporting the full domain as a happy accident. My guess would be that it gets that and it creates a location header in the response, and location can be either relative or absolute. So they're expecting it to always be relative, so they're just echoing back whatever the value is. And by a happy accident for the attacker, when they do that and they provide an absolute value, it works out. But my guess is they're just not validating it at all, and so whichever you provide works in this case.
Yeah, they just don't even consider it like in the scope of untrusted input, which again is like another thing, is that typically when you see these type of like state things, we have seen them a few times before. Typically there is some attempt at trying to obfuscate it or encrypt it, because a few of our topics have actually talked about how that's not even enough in and of itself. But here, like, that's not even it's just the base 64 encoding of it. There's no attempt at securing it or anything. So yeah, I agree, there was a few things with this auth flow I was like, that's pretty interesting. It deviates from what you typically see.
Yeah, like, it just seems like there's something a bit more complicated going on here that I'm just not aware of. Because it does use the whole, account.booking.com/OAuth authorized endpoint. It uses that, goes to the redirect. So it's possible what's happening here is this, like, it hits that for all of these URLs, including this one. It hits that endpoint, sees like, hey, they're logged into booking.com, so it just immediately does the auth callback, which is the redirect URI, which then processes this. That just seems like a really overly complicated auth system. But then there isn't necessarily, I guess the state value should be unmodified through all of that, so they could maybe do some integrity checking. But yeah, this one does feel like the auth system feels weird, but it's neat to kind of see it get abused.
Yeah, and something else I like from this blog post too is seeing the mobile app being tied into it. Now they were kind of forced into that path, like they didn't really have any other choice. But it's been a while since we've covered a post that leverages like abusing a bug in the mobile app to hijack an account. The idea there, for those not familiar with how that would work, is basically you'd use like Frida or something to hook the app and do your malicious flow. But yeah, it's fun to see that. You don't get to see it too often because generally like you said, when you get that code, it's typically it's game over. That's the end of the pose. So, but yeah, not in this case.
Yeah, and it is worth noting, like on Facebook side, like that is assuming the users. So this is talking about that redirect URI validation. Like assuming the clients or the users are not doing anything too stupid, like that can actually be reasonably effective at preventing some of these attacks. When you need to expel it over an open redirect, if you just don't validate that open redirect or something, it's honestly a reasonable mitigation that I haven't seen talked about much.
Yeah, it's
Like,
pretty good defense in depth.
yeah, it doesn't add much in terms of like overhead. It's not like it's hard to do that sort of validation. Some setups, it can be hard to actually figure out that URL or do that really nicely, depending on how you do the catching back. Like if it's static endpoints that you always catch back the same thing, fine. But if you do something per user, it can get a little bit more tricky. But yeah, I don't know. I just haven't seen others talking about that. Maybe I've stated this before. When I did kind of my consulting days, I didn't end up running up a lot with OAuth verifications. I did a lot more like internal apps and other stuff there. So I didn't do a lot of testing or something. Maybe it's just something really stupid that everywhere supports and I just wasn't aware of it. But I don't recall this really being mentioned. I mean, obviously you could switch to like an implicit, or if you can switch to an implicit flow grant, then it's going to be pretty easy to leak the token anyhow. This is using the code grant. So I don't know. It's interesting to me. I feel like this is one of those things that could just be exposing my ignorance on the topic though too.
All right, so we'll get into our next post, which is from GitHub Security Blog. Or no, sorry, I was getting ahead of myself a bit there. Yeah, so we'll get into some poor use of crypto, actually, which is a post on breaking Bluetooth smart locks made by Megafeis. So, and yeah, while this post does go into a good bit of background on Bluetooth and the technology involves, what it ultimately comes down to is really poor authentication flow validation and trusting that MD5 will keep you safe. So yeah, they did some research on this, inspected the request packets and the traffic going back and forth between the mobile device and the lock that had the Bluetooth on it. And they noticed that the lock would talk to the phone over BLE or Bluetooth Low Energy. And the phone app would communicate with the like backend server with the HTTP API to perform various actions such as binding and unbinding locks to the account. Now that's kind of the first fail, the fact that HTTP is being used here. It's kind of insane that TLS or SSL isn't being used in something like this, because the request can be tampered with in flight, which is what the attack leverages. They did notice, though, that there was some protection they tried to do, because if they tried to modify the request, they got an illegal access to resources, your IP has been recorded kind of scare message. And looking closer at the HTTP headers, they noticed that there was this like security sign digest header being sent with the post requests, which contained an MD5 hash of the request. But of course, this is a super weak scheme. The fact that it's MD5 and one of the weakest like hashing algorithms there is aside, the algorithm they use to generate it is also like pretty easy to reverse and doesn't really contain any secret. they figured it out by just simply like taking the date, the data, this like app slash app slash string, and a fixed string of okay lock, and that would spit out the digest that the server would then try to validate. So yeah, no secret, no asymmetry really. Kind of a classic misuse of crypto problem,
I mean,
as they try to ensure integrity of the request, but they basically have like no form of auth checking or ability to guarantee that that hash can't be generated by the attacker. So
yeah, the OK lock string is acting here like you would use a secret. Um, and honestly, even if they used any sort of actual secret value, it would have been needed, or it's needed in the client. The client needs to be able to see this value. They would have been able to expose it. So even if they were using some secret, it still would have been uh, fairly broken here. I mean, they really just they needed law or they needed auth checking, but were you still going to talk about that or any more on
no,
there?
I was just gonna say basically this entire like idea and mechanism for authentication is just fundamentally broken.
Yeah,
um,
it's at best only an integrity check, and it assumes that an attacker will not reverse engineer the application. Like that's what it's relying upon, because other than that, it's only validating the integrity of the request. It assumes any request that is signed, uh, using air quotes for signed there, any request that is signed is valid, so they're able to then use that to hit any lock they want and say nope, this, or unbind the lock and say nope, this lock belongs to my account now, and use it however they want. Like they can do anything because there's no auth checking. There's only this thing that says the application legitimately signed this, and their process actually determined that was legitimate is pretty broken. The fact that they're using MD5, I mean, you don't want to see MD5. You just generally try and avoid it because of collisions and stuff. But collisions aren't really the biggest issue with this sort of setup. Like, even if they're using, Whirlpool or Shaw, one of the Shaw families, like, even if they were using something stronger, it's still broken as long as you can
yeah,
expose what information's in there. And yeah, there's nothing hard about that. It's like MD5, crazy to see, and it's a bad sign to see it for sure. Like, it's code smell. There's probably things going wrong here. But it's not broken because of the MD5.
it's not the core issue. No.
Yeah. Core issue is lack of auth at all. Like, if they were simply checking the user's cookies, because they do have to log in, they do have some cookies here. If they were checking those, this suddenly wouldn't have worked. Because you'd still need to be logged in on the right account. But they just don't. So yeah, really stupid issue. But as a post, good post with a lot of background and a lot of kind of process information, a lot of information about the process they went through to discover and work their way through to the final bug. So there's a lot of stuff that we skip over, but that was a fairly well done post. And I guess it was done as part of an internship, so a lot of those intern posts tend to have a lot of that background and process information, which I super appreciate. Just having the references for that.
Yeah, I think like if I was to try to think of what could have been done differently for like preventing the style of issue, aside from doing proper authentication and not just validating the integrity of the request, but yeah, like first of all, TLS should have been used, but secondly, like this custom rolled signing scheme with MD5 should have been avoided, and they should have went with something that was designed for doing this. So like maybe like a SHA-250 SHA-256 HMAC, where like the key was kept secure in the device or something, because like Android does have the ability to have like secure key storage. So it seems weird to do this like really it is custom rolled crypto essentially.
It's
So
their own crypto system. Because custom
yeah,
rolling crypto doesn't mean implementing AES yourself, although it does mean that too. It also means not creating your own custom crypto schemes.
yeah. So I think taking advantage of like existing schemes instead of trying to do this weird thing would have been a lot more beneficial. But yeah, that's those are like the two major things I think could have been improved with their off flow of the requests themselves.
Yeah, I mean, almost any system though that you can do here, good shout on, like, if you're able to pass off the crypto to the device so you never actually see the keys on the client. If you're able to do that, that would be a lot more ideal. Although when you talk about the HTTP HTTPS, I'm not sure that, so there is sort of like cert pinning that you can do on mobile devices, but HTTPS isn't really that much of a mitigation or really a factor when it comes to a lot of mobile apps. If you've got
Well, the
something like
HTTPS
Freedom.
was more just like like why not use it?
Oh, I
It
agree.
protects requests better, right?
Yeah, no, I agree. Like,
Especially from like
again,
MITM type stuff.
yeah, again, it's one of those code smells. They're doing something that, like, years ago was a red flag. So doing it now is pretty crazy. Again, using HTTP is one of those things, as is the MD5. So I agree with you there. Like, I'm not arguing that just using plain HTTP is totally fine. Just, I don't think it would have prevented much here with tools like Frida. You just hook it before it gets encrypted, after it gets decrypted, do your changes there, and away you go.
Yeah. Which is where I think the device, like using like CCP or whatever on the Android device would be a benefit.
I think just having proper server-side auth would have
Well, that as well,
been
but
like the
I was
most.
kind of
I
thinking
know
on
you
the
said,
other side of it.
yeah, you said besides that, but it's like implementing this as a proper web app would have been, the way to go, because that's not something that can
Yeah.
be broken, and like, it's how you would usually do it. Like, even the whole
Yeah.
signing thing, like, shouldn't even be necessary if the web app was done well. Like, you only need the signing aspect of it because you don't want to keep track of any auth on the server.
Yeah, it is like shifting responsibility in the wrong direction. But it's fun to think about, so that's why I was trying to think of like how this could be done better on that side of things. But yeah, I mean, ideally you do the authentication on the side that can't be tampered with. So
Yeah, and
yeah.
actually, on that point, I'm not. Or I guess this is a standard mobile app. I was saying this was in a web view for some reason. I was going to say I'm not sure how much access you'd have to onboard crypto from the web app. I've not worked with that before, but since this isn't a web app, that doesn't matter anyhow. They have access to everything.
Yeah. All right, so now we will get into that GitHub security blog post I mentioned earlier, which was where GitHub Security Lab audited DataHub. So for those not familiar with what DataHub is, I haven't really used it either. It's like an open source metadata platform. It's used by like governments and corporations and stuff. It seems to be a pretty big like ecosystem. And some of these issues that GitHub Security Lab found included deserialization issues, SSRF, XSS, and more. Overall, there were like 10 issues reported, 7 of which were acknowledged and fixed, 3 of which were deemed won't fix or not issues, which was like an open redirect, AES ECB being used, and another bug that isn't really detailed. Which yeah, they don't really go into detail on those either, but yeah, we won't go through all of them because there is quite a few, but there is a few interesting ones. The funniest one that I saw was probably like just a missing JWT signature check in the stateless token service, metadata service. That one was pretty simple, where like this stateless token service would parse from using this JWT parser lib, and that function wouldn't implicitly perform any validation, so you can just pass any JWT. For regardless of algo for an auth bypass. It was, yeah, this is kind of a funny one to see in there. But another bug that I wanted to call out that I thought was interesting was a login fail open issue. So I'm just going to search that up for people who are watching. So yeah, this was in their Java Authentication and Authorization Service, or JAS, and in the code they try to, like, they have this authenticate JAS user method, and they have like a try catch to do some exception handling. So they would try to instantiate the login service, open the configuration, parse that, and set up a context. The problem is if there was like a misconfiguration issue, um, and the configuration issue they parse has a bug or doesn't exist or something like that, it'll throw a login exception, and the only exception that they try to handle is a login exception. For a generic exception, they have this comment saying that this should never happen. like basically their thinking is that this case can't be hit. So it's just an empty code block. There's nothing there. So if you can trigger an IO user exception, or an IO exception, that can basically just allow auth bypass because of this fail open case. So I thought that was a bit interesting. It's not too often you see exception handling, breaking the application in this way. Um, fail open in this kind of situation is just kind of a stupid design philosophy to have, and it's just lazy because they didn't want to handle that exception case. But yeah, it's kind of fun to see.
It's fun to see. This was actually we had a spot the vol not too long ago that was basically this issue. Simpler code because I'm too lazy to find, or sometimes too lazy to find all of the real code for it, but exact same sort of setup where you have the exception that breaks the auth flow and it just continues on. I've seen it in a number of places outside of the auth, and where it shows up can be a little bit surprising. It's also just one of those things that when it shows up, it's not necessarily as impactful as like in the auth flow. But trying to create exceptions is, a very valid way of trying to create bugs and trying to find bugs because, exceptions often are the least tested area of the applications.
Like I like to say, error handling and exception handling is one of the least fun things and the least glorious things to do. So it's very easy for people to get lazy or just not check that it's being done properly because nobody likes to deal with it generally.
Yeah, or just exceptions to kind of change too. That wasn't the case here, but it could be the case where like, oh, this case couldn't be reached before, and then somebody added in a new exception somewhere, and all of a sudden, you can reach this in a reasonable way. I don't know I don't think that's the case here, but that is something I have seen a handful of times too. Some of the other issues on this, I thought the JSON injection was kind of fun. The application in the auth service client would generate these strings just using format strings to create like, a JSON object that basically just not, or to get away from using an actual JSON serializer, they would just use a format string, give it the key, give it the value, and work from there. The problem was that, since an attacker could control something's values, an attacker could include a quote in their value and break out of this formatting. So they have a couple places that this happens. The one that actually, so they have two proof of concepts. One doesn't really work out, so I'm just going to look at the one that does, which is creating an account for the system user. So this endpoint, the service, kind of handled user registration, handled creating access tokens, verifying the credentials, and all of that. All the auth stuff, basically, being the auth service that makes sense. So what they were able to do was they were able to craft the JSON coming in here for a sign up, and for the email address, they would provide this lovely string, which just included several escaped double quotes. So when that gets read by the application creating the JSON string, I'm not sure exactly which one it was for here, but you can see it's just using the string format, key and value. So it doesn't look for quotes anywhere. Doesn't look to see if there's a quote in what they're putting, so you can escape the JSON value and start injecting your own keys, which they're then able to abuse. And in this case, they inject a new user URN, which has this DataHub system value, or at least that's the important part of it, because that DataHub system is kind of a special URN that is used for the system account, so highly privileged account. And it'll go through and it'll add, or it'll have this URN, so when it hits the rest of the endpoints, it'll end up reading, or it'll default to using the URN injected rather than the URN kind of added legitimately. So this does also kind of rely on the parsing order of having a URN in one place versus, or having it more than once, sorry. But effectively, this would let them just create the account there, create that special account, despite the fact that their user ID or their email wasn't that, but injecting the system account, creating the system account, and having or higher privileges. The first proof of concept that they talked about was just generating tokens for arbitrary accounts, working very similar, where they would include the user ID as the special one, and when it does kind of the whole checks, the one request ultimately ends up having these two user ID keys in it, and it just trusts the last one, so they're able to do that. However, for basically having some invalid characters in one place, that attack doesn't work, but this creating the account does, so they're able to create a highly privileged account. I thought that just a really fun attack. Seeing the injection to JSON is just a fairly fun issue. One of the other issues that they had is just kind of a classic thing where they have a privileged header that's X DataHub actor header, which would be used to say what user an action is being performed on behalf of. And they have this code here, so when it's proxying requests, it goes and it looks for that header. The problem is it does that check as a case sensitive check. So it looks for that header with specifically that capitalization. The backend, however, doesn't care about capitalization. So you can basically smuggle in a request with a different DataHub actor, and the backend will use that. Fairly straightforward issue. Those are kind of my two favorites out of these. But yeah, they do have a few other, in my opinion, less interesting vulnerabilities here too.
That JSON issue, I've got to say, it's kind of insane to see format strings being used to build up the JSON like that. I don't think I've ever seen that before. It just seems insane to not use an actual like purpose-built JSON serializer for that. That seems to be just asking for problems. Yeah,
Then you need to
I
get
can't
that,
even really rationalize that one.
that dependency approved and go through the whole process, because I don't believe there's anything to do that built into Java. You would need to use a third-party dependency or implement it all yourself.
I
So like there
guess.
are libraries that would do it, but when you start getting into some corp code, I've seen the hacks like this done a number of times because there just isn't a really convenient option in a lot of cases. And yeah, IABR mentions, sadly seen that a lot, but at least mostly on IoT stuff. Actually, now that you mentioned, I think we've actually covered some IoT things that have done this too. Maybe we didn't have the vulnerability there, but I think we've seen similar code on IoT. Obviously not Java in that case. Most IoT devices aren't running Java.
Yeah. But yeah, like there's a mix of issues there. We only covered the ones we found the most interesting. But as always, the link will be in the show notes. So if you want to check out the post and check out some of the other issues, you can go ahead and do that. But yeah, in the interest of time, we're gonna skip most of the other ones. But yeah, I think the ones we covered were pretty cool. And yeah, that JSON one, like doing that injection, it's a neat like exploit. It's pretty like specific to the scenario, but still, it's cool. All right, so we'll get into our last vulnerability, which was two vulnerabilities in ImageMagick, which is the open source utility for viewing and working with image files. I think we've talked about it before. I think Talos has found some issues in it before. One
There's
of the
always
vulnerabilities,
ImageMagick issues go around.
yeah, yeah. I mean, image parsing and stuff is harder than some people might think. But yeah, so one of the vulnerabilities that was detailed here was a DOS. So I won't go into it too much since it's not super interesting. Giving like a quick Cliff Notes version of it though, ImageMagick could parse PNG files in an effort to convert them. And if the PNG had a textual chunk type with a profile keyword and a value of dash, it would try to open stdin and read from it, and it would just hang, and it would be unable to process further requests. So kind of a straightforward DOS. The other vuln was an info leak and was based on a similar thing with PNG and textual chunk types. Again, it involved the profile key and value pair. But this time, instead of passing a dash, you could pass a local file on the system. So in classic fashion, the example they use here is Etsy password. And they can try to get that loaded into the image. And so you can then download the resized image, post-processing, and potentially exfiltrate the leaked file contents. So fairly non-standard bug that can have some high impact. It does kind of depend on, what privilege level ImageMagick is running at. If the system that's running it is doing proper, due diligence and sandboxing and stuff, you are going to be quite limited in what you can open and leak with this exploit. But if it's put on carelessly or whatever, like it is in their example case with being able to open Etsy password, it could be pretty impactful.
Everybody should be able to open Etsy password. Like that usually Etsy Shadow
Sorry,
is
you're
usually
right.
privileged off. But
Yeah, I was
Etsy
thinking of Shadow. Yeah.
Yeah. But Etsy password is generally needed. That said, like ImageMagick will often run with the privileges of like the web server. So www data, something like that. So lockdown, but still access to some of the web stuff. At least a lot of times I've seen ImageMagick in use. That's kind of the case where you'll maybe be able to exfil, PHP apps, you'll be able to get its source, which is definitely useful even when it is locked down a little bit. It will usually or often have that because it's writing web files, things that are going to be read by the web server and such, and not completely locked down. So I think source would be a viable thing to exfil with this on PHP apps, and of course PHP apps like to use ImageMagick. Python, I think you see more like pillow usage. So yeah, I don't know. It's interesting. I thought it was just a neat little bug, like not something you'd really think of unless you're looking at the code and realize, hey, it does this. Yeah, I don't know. It's a fun thing because you don't I think of code execution when it comes to ImageMagick. Not just. I mean, I think there have been some other issues that will leak files, but I don't know. It's a weird feature to have, but kind of fun for the attacker if you run into this somewhere.
I guess part of it is just that it's easy to think that PNG files are pretty simplistic files that don't really have any complicated features. Most people aren't looking at the textual types and whatnot that can go into PNGs because it's just the typical start data end sort of deal. But yeah, there is some more complicated stuff you can do there, and that's what this exploit takes advantage of in ImageMagick. So yeah, it's kind of like a hidden functionality almost.
Yeah, and I'm
So
not sure what the profile is supposed to be used for here, or what the intended functionality is to be able to read a file in. It could be profile makes me think of the color profile, so it could be expecting to read it that way, but you still wouldn't expect a remote file to be able to point to a random file somewhere. So I don't know. There obviously is some functionality that's expected with this, but I just don't know what it is or what the intended use case is. So looking at it from my, dumb image understanding, it just feels super weird.
yeah, I mean my familiarity with PNG isn't much beyond it can display pixels. So I've never really had to work with images at low level data manipulation stuff. So if somebody does have some knowledge of PNG and what that profile is used for, feel free to use a comment or put a comment on that because I'd be curious on that. But yeah, that's all the vulnerabilities that we have. We do have a few shoutouts. Z, I'll let you get into that and then we'll wrap it up.
CI/CD tricks, quick shout out on that. It really just talks about different, some tricks when you're targeting some of the CI/CD setups. They talk about Azure, they talk about GitHub Actions, I believe. It really is just a bunch of tips and tricks for ways you can abuse if you had a degree of access already. It's not necessarily a vulnerability exactly, but if you want to escalate one of your attacks, something you might be able to do there. So it is just some tips and tricks there. So not quite how we would usually or what we would usually cover, but still worth a shout out for your own research if you find yourself in that scenario. The second the second shout out was this new vector for dirty arbitrary file write. So if you've dealt with a dirty arbitrary file write before, that's basically where you have a file write that you could write to any file, but what you can't do is control all of the data in that file. Usually there will be some header, or imagine you're writing a log file. There's going to be other data in there and a little bit of attacker controlled data. So in this case, if you have that, they basically talk about targeting the UWSGI configuration file just as an option here and kind of showing how you can get code execution if you can overwrite that file. That's going to depend on having an application that uses such a file. So mostly seen with Python applications, if I recall correctly. So a little bit limited on that, but it's worth seeing some attacks that you could use if you have that. So again, just a shout out for something to look at if you end up in that scenario.
All right, so that's all we have for today. So thank you everyone who tuned in. If you want to catch past episodes, you can find recent ones on Twitch and all of them on YouTube, Spotify, Apple Podcasts, and more on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. We'll be back tomorrow at 7 p.m. Eastern, 4 p.m. Pacific for the binary topics, and we'll see you then.